Hello everyone, I am Dr. Sathish Kumar, Assistant Professor in Sri Ramakrishna Engineering College, Coimbatore. In the last session, we discussed about fundamentals of psychrometry and psychrometric properties. So, in continuation with that, today we are going to discuss on psychrometric chart, how to make use of it, and also we are going to discuss about psychrometric processes, and we also going to solve few problems to identify or to determine the psychrometric properties using psychrometric chart. So, let us get into this video. So, basically what is the psychrometric chart? It is a useful tool, right. So, it is a useful graphical representation of thermodynamic properties which we discussed in the previous session, right, present in the moist air or unsaturated air. So, this psychrometric chart consists of lot of lines. So, few lines are linear or straight lines and few lines are curved lines. So, let us start from the x axis and y axis of this psychrometric chart. So, as you see here in the x axis, in the abscissa, we have a temperature, dry bulb temperature. In the y axis, we have two things. One is specific humidity or humidity ratio, and we do have vapor pressure here in mm of Hg, PV, vapor pressure here. So, these are the x axis and y axis of the psychrometric chart. So, also we do have certain straight lines or linear lines, right. So, we call it as what, wet bulb temperature line, right, specific volume line, and we also have some curved lines called relative humidity line, constant relative humidity line, and we also have provision to calculate the enthalpy of the moist air if a state point is fixed in the psychrometric chart. So, this is called the enthalpy scale, and the constant enthalpy line is also present here. So, since this is too clumsy showing everything in a single chart, so let us just do one thing, let us see one by one from the next slides. So, let me just show you the constant dry bulb temperature line, constant wet bulb temperature line, constant specific volume line, and so on, and separately those lines alone in a psychrometric chart, right. So, let us start from dry bulb temperature lines, right. So, dry bulb temperature lines are the vertical lines, these are represented vertical straight lines, linear lines, right. If I fix a, suppose say if I fix a state point here, this is my state point, right, then I can tell you the dry bulb temperature for this condition. So, draw a vertical line, and this is around 27 or 28 degrees Celsius. So, if the state point is here, the dry bulb temperature is 35. So, it is merely what, draw a vertical line and take the value from the x axis. So, this is dry bulb temperature, this is dry bulb temperature. So, it is measured as we discussed in the previous class, this is measured using ordinary thermometer with this bulb dry without any moisture. Specific humidity lines. So, specific humidity lines are linear lines which is a horizontal line. So, if I have a state point here, then the specific humidity, to find the specific humidity we have to move right in a horizontal manner to reach the y axis, where you have what, specific humidity values written in the y axis. So, 15 or now it is around what, 16 kilogram per kilogram of dry air is the specific humidity value of the moist air whose condition is here. So, now what is that, we want to take the dry bulb temperature, move down vertically, you take the value here, dry bulb temperature value say 20 degrees Celsius, right, 16 kilogram per kilogram of dry air. So, this is the values of dry bulb temperature and with humidity ratio or specific humidity, directly we can take from the psychrometric chart, right. So, we can also note that if the humidity is high, on the other higher side, this is process 1 and this is process 2, right. You can notice, you can take the humidity value straight away, and if this is the process, this is the dry bulb temperature value, right, dry bulb temperature value. So, let us say, so the humidity alone is increasing here, right. So, this is the measure of the moisture, exact moisture content present in the air. If its value increases, then I can say the moisture content increased. The value of specific humidity decrease, then I can say the moisture content has decreased. And next is dew point temperature line. So, dew point temperature line, we need to draw two lines. So, in dry bulb temperature, to calculating while measuring dry bulb temperature and specific humidity, we made only one line, vertically downward and horizontally rightwards. Now, to find dew point temperature, we need to make two straight lines. Suppose, say, if this is the state point, if my state point is here, then first I have to make a horizontal line till this line hits this curve. This curve is called saturation curve. This curve is called saturation curve. I think by this time you should know what is saturation, meaning of the term saturation, saturated air or saturation curve, where along this curve relative humidity is 1 or 100%. The air has got maximum moisture in it. So, till it hits the moisture saturation curve, and then you have to draw a horizontal line. So, to get the dew point temperature. So, this is the dew point temperature of the air which is at this condition, right. So, specific humidity you can take straight away, specific humidity value. To get the dry bulb temperature, you can take this way, dry bulb temperature, and this one is dew point temperature, dew point temperature. So, so far we have learned how to calculate the dry bulb temperature, specific humidity and dew point temperature. Dry bulb temperature vertically downwards, specific humidity horizontally rightwards, dew point temperature first move towards left horizontally, leftwards and vertically downwards, two lines, consecutive lines. We have wet bulb temperature lines. So, wet bulb temperature, as we discussed in the previous class, this is a very important property. So, wet bulb temperature is definitely less than dry bulb temperature. This reduction is due to the cooling effect, especially due to what? Evaporation happening in the wet bulb. So, evaporative cooling is the cause for reduction in the wet bulb temperature compared to dry bulb temperature. So, very important, and here too we are going to make two lines, but in what way? For example, say if this is my state point, if this is my state point, how to calculate the wet bulb temperature? So, these lines, inclined straight lines, are called constant wet bulb temperature lines, right. So, we have to move, if the point is present between any two lines, we have to move parallel to the line, parallel to these lines, right, this way, parallel to these lines till it hit the saturation curve, and from here on we have to move vertically down. So, these two lines we have to make to find out the wet bulb temperature. One, first line move parallel to these constant wet bulb temperature lines till the line hits the saturation curve, and then come down vertically till it hits the dry bulb temperature, I mean the x axis. The x axis we have the readings, right, temperature readings. So, here it is approximately say 23 degrees Celsius. So, what is this 23 degrees Celsius? Wet bulb temperature. So, what is the dry bulb temperature? Merely move down and read it, 25 to, this is approximately 30 degrees Celsius. What is this? Dry bulb temperature. If you want to measure dew point temperature, let us recall how to take dew point temperature. Move horizontally in the left direction till you hit the saturation curve and then move down vertically, and this is 16 degrees Celsius. So, this is dew point temperature. dew point temperature. So, from this what do we observe? Dew point temperature is the lowest when compared to wet bulb temperature and dry bulb temperature. So, which has highest value for a particular condition of the moisture? Dry bulb temperature is greater than wet bulb temperature, and wet bulb temperature is greater than dew point temperature. So, this is the order, right. Okay. So, let us discuss one important point here. At one condition, all these three temperatures will be same. Already we have discussed in the previous lecture, wet bulb temperature and dry bulb temperature are equal at one condition. What condition is that? Saturation, when the air is saturated. For saturated air, for saturated air, we studied wet bulb temperature is equal to dry bulb temperature, and now let us add one more thing, this is equal to dew point temperature as well. So, let us graphically see that how it happens, right. So, what line is this? Actually, what line is this? This is the saturation line. So, this is saturation line where relative humidity is 100%, relative humidity is 100%. If I take a point in this saturation curve, so what point is this? Right, a point at saturation point, right. At this point the air is completely saturated, it has got 100% moisture, relative humidity in it and specific humidity in it, right. So, what is the dry bulb temperature? Draw a vertical line. Dry bulb temperature is 25 degrees Celsius. What is the wet bulb temperature? You have to move, if we would have the point somewhere here, we would have travelled along this line till it hits this point, but this point itself is on the saturation line. So, we cannot move further out of the saturation curve, right. So, out of the chart. So, already it is there. We want to take the wet bulb temperature, draw a vertical line from that saturation curve, 25 degrees Celsius. What is dew point temperature? If the point is here, we would have moved this way, but the point itself is there already in the the saturation line. So, again just move vertically down. So, all these three temperatures are 25 degrees Celsius. So, that is why we said when the air is completely saturated, for saturated air, all these three temperatures, dry bulb temperature, dew point temperature and wet bulb temperature are equal for saturated air, right. Next, and specific enthalpies. As I said in the previous session, enthalpy is a very important property which is used to measure the heat added to the system or the air, moisture or heat removed from the moisture or the load, heat load present in the air, right. So, here we find a specific enthalpy line, right, specific enthalpy line, right. If you have the state point somewhere here, then you have to draw a line parallel to, these are constant specific enthalpy lines which are running parallel to WBT line, the wet bulb temperature line. So, both are almost same, right, overlapping each other, right. You have to draw and move out of the saturation line till it hits this scale, enthalpy scale. So, you will be having the value in kilojoules per kilogram, specific enthalpy, right. So, after the process, if you have some value, say somewhere here after the process, right. So, you have to draw a line parallel to the constant specific enthalpy line till it hits the value here. So, this is H1 and this is H2, and this value H1 minus H2 will give you how much heat would have been removed or added from this, or how much load, heat load can be added or removed from the air system, right. Delta H is a very important property. Here, for example, in this case 1 to 2 is this process, here you can notice what? T1 equal to T2, there is no change in temperature, dry bulb temperature, but still I can say some load is removed from it. What kind of load? As I already told you, in the previous class, enthalpy is the sum of enthalpy of the dry air present in the mixture to enthalpy of water vapor, and this is the sensible heat. The contribution of the sensible heat is nil, there is no change in temperature, but this is what? Latent heat load. Latent heat load. Here you can find specific humidity has increased. Specific humidity has increased, right? So the contribution of this from what? The increase in the decrease in the specific humidity. Decrease in the specific humidity, right? So this amount of this latent heat load is removed from the air. Humidity is reduced, right? Specific volume lines, constant specific volume lines. So unlike constant enthalpy and wet bulb temperature line, so we have one more thing called constant specific volume lines. So the inclination of this line is slightly more than the constant wet bulb temperature line. Constant wet bulb temperature and enthalpy lines overlap each other, and this will be like this, right? These are WBT and constant enthalpy lines, right? Both are same, and this is specific volume lines, right? So the values you can notice here, right? The value will be written somewhere over this line in the psychrometric chart. So how to differentiate this? If you have any confusion, just get into this unit. The unit will tell you what line is that. Meter cube per kg. Meter cube is the unit of volume and meter cube per kg is the unit of specific volume. So from the unit you can confirm which line is that, constant specific volume line, and you can differentiate what? Constant enthalpy line and wet bulb temperature line. Okay, right. Next one is constant relative humidity line. So as we saw here, this is saturation curve. Here the relative humidity is 100%. So all these curved lines running parallel to this saturation curve line are called constant relative humidity lines. Constant relative humidity line. So along this line the relative humidity is 80%. Along this line the relative humidity is 60%. Anywhere on this line the relative humidity is 40%. Likewise 20, and here to have what? 10%, and so on. So these are called constant relative humidity line. If I have a point, state point here, I can say the relative humidity is around 30%. So the problem in psychrometric chart is we can only tell you the approximate value, not the exact accurate value, right? But we can quickly get those values and we can get an idea about the processes happened. So let us next move our discussion towards psychrometric processes. So these are the important psychrometric processes which is normally used in the in the field of HVAC or air conditioning to keep the conditions at the required level, right? So let us now see one by one. So let us just list out, quickly go through the processes involved, right? The first process is sensible heating process, sensible heating and sensible cooling. So here the temperature of the air alone is raised or reduced without changing the moisture content or specific humidity or humidity ratio. Without altering this value, only the temperature alone is raised or cooled during heating and cooling process. Such process is called sensible heating or cooling. And the second is cooling and dehumidification. So cooling, this is the process normally used in most of the Indian conditions, Indian climatic, in tropical countries they go for this, right, tropical regions during summer, right. So during summer they go for cooling and dehumidification. They will try to reduce the temperature as well as reduce the moisture content and bring down to 40 to 60 range to keep the human comfort, to feel the human at a comfortable condition, right. So, next process is heating and humidification, opposite to this, right. Heating and humidification. Where do we need this? This is needed where the condition is too cool as well as the air is too dry. So, which is uncomfortable, which might feel uncomfortable for humans. So, for those countries or regions, we go for heating and humidification. The last process, next process is humidification. Humidification is without changing the temperature, adding the moisture content of the air. Dehumidification just opposite, vice versa, without raising or lowering the temperature, reducing the moisture content, dehumidification. Next, cooling and humidification. In certain regions, the temperature, air temperature may be too high and high as well as dry, cooling and humidification. So, in places like say Rajasthan, in Rajasthan and Delhi, the climate may be too hot and the air may be too dry. In those regions, we should go for what? Cooling, as well as we have to humidify the air by spraying the water particles, right, suitable water particles, and it will improve the moisture increase the moisture content and bring the humidity level close to 50%, right. This is the cooling and dehumidification we need in places nearby coastal regions. Hot, but moisture content may be high in place like Chennai, Kochi, Bombay, Kolkata. During summer, we need to cool as well as dehumidify, right. And the last and important process is adiabatic mixing. So, in air conditioning, normally we need to mix fresh air along with the air present in the conditioned space. So, the air in air conditioned space, normally we used to keep the space airtight. So, we normally do not leave gaps in the windows and the doors, right. So, if the occupants are going to be more, and at one time the occupants will feel uncomfortable if the carbon dioxide content is raised or oxygen content come down below 20% or 19% present in the air. So, in that case we need to keep on mixing the fresh air consistently, right, and periodically. So, in that case the fresh air what we mix, we take from the atmosphere, which may be at different temperature and which may hold different moisture content compared to the air present in the conditioned space. So, when you mix these two and send into the conditioned space, what happens to the mixture? So, this is what is studied in the adiabatic mixing process. So, this is also an important psychrometric process. So, let us quickly practice few problems to make use of, just know how far this psychrometric chart is very much useful in identifying the properties. So, before getting into that, a very basic thing is we can fix a state point not only in the psychrometric chart, in a ordinary graph sheet. If you want to fix a state point, for example, during our schooling we would have made lot of graphs, right. So, if our teacher asks you to make, say, mark the point A 2, 4. So, what do you do? So, we mark 1, 2, 3, 4, 1, 2, 3, 4, right. So, we go for finding out, we know this 2 is x axis, x coordinate, and 4 is y coordinate, and we draw a vertical line from here and horizontal line here, and the point at the intersection of these two is what? Point A. This is the first exercise we did using graph during way back in our 5th, 6th standard in our high school, right. Now, the same case is applicable here. So, in the psychrometric chart we have already marked what? Dry bulb temperature, we talked about wet bulb temperature, dew point temperature, and we talked about specific humidity, specific volume, enthalpy, and what else? and also this constant relative humidity line. So, 7 parameters we have discussed, right. So, to fix a state point not only in this graph sheet, also in this psychrometric chart, minimum we need 2 properties out of this 7. Out of this 7 we need minimum 2. Without minimum 2 properties, it is not possible to mark a state point in this graph. So, whenever we get a problem, we should try to get 2 properties from the given data, so that we can mark that state point and take the remaining properties from the very easily from the psychrometric chart. This is what we are going to practice now. So in this problem, what is given? Dry bulb temperature is given as 30 degrees Celsius and relative humidity is given as 50%, and we are asked to find out wet bulb temperature, humidity ratio, dew point temperature and enthalpy. So hardly it may take just a minute time to find out all these 4 properties. Within seconds we can take. So once if you able to mark the state point with these 2 properties, rest of the things can happen in seconds. Let us just move one by one. 30 degrees Celsius, where is dry bulb temperature? In the x axis. In x axis, let me just, so now I think it is visible, it is 30 degrees Celsius is here. 30 degrees Celsius, right. 30 degree, draw a vertical line from this 30 degree Celsius, right, and 50% RH. So where is 50% RH line? Here, 50, 60, 70, 80, 90, 100. So this is relative humidity line and this is constant 50. You have to draw the vertical line above this way till it hits the 50% RH line. So this is the state point what we want. So we got the state point at the intersection of these 2 constant property lines, constant dry bulb temperature line, constant relative humidity line. You draw these 2 lines, the point of intersection of these 2 lines will give you the state point, required state point. From here on we can very quickly finish the remaining part. Calculate WBT, wet bulb temperature line, draw lines, a line parallel to constant WBT line. Though these are constant wet bulb temperature lines, you have to draw till it hits a saturation point. From here draw a horizontal line. And what temperature is this? 21, 22, 23 degrees Celsius. So approximately 23 degrees Celsius is the wet bulb temperature. And humidity ratio. How to find out humidity ratio? Just a horizontal line towards right. In the y axis we have humidity ratio 14, right, straight away got 14. What is the unit? Kilogram per kilogram of dry air, right. So how to find out dew point temperature? Move towards horizontally in the leftward direction till you hit the saturation curve, then draw a vertical line. We end up here 19, I think so, 19, around 19 degrees Celsius, approximately 19 degrees Celsius. What is the enthalpy value? Enthalpy, constant enthalpy line and constant WBT line, wet bulb temperature line are same, overlapping, right. So you move along this line, you extend this line till it hits the enthalpy scale. So enthalpy is in what? Kilojoules per kilogram. 60, 61, 62, 63, 64. So approximately equal to 64 kilojoules per kilogram of dry air. So that's all. Within seconds we have finished. So this is how we are using the psychrometric chart, and very easily we can take all other properties just if you know any 2 properties out of 7 present in the psychrometric chart. So let us extend this further and solve real time problems using various psychrometric processes in the next session. So, thank you all for watching. Thank you.